Ask my instructor 3.7.26. In order to find the equation of the line tangent to the graph at the given point, I'm going to have to use implicit differentiation. Implicit differentiation is kind of a fancy word, but really all we're doing is the chain rule. Notice this derivative. Let's just look at it. I'm taking the derivative of x squared. I'm taking the derivative of x squared with respect to x. The letters match up. So no chain rule is needed. The derivative of x squared with respect to x is 2x. What about the derivative of y squared with respect to x? Here the letters don't match up. After I take the derivative of the outside, I'm going to have to take the derivative of the inside. Y is a function of x. So I bring down the 2 and it's y to the 1 power. That's taking the derivative of the outside. Now the derivative of the inside. The inside is y. The derivative of y is dy dx. So the derivative of y squared is 2y dy dx, or 2y y prime. Okay, let's look at it one more time. In the first line, the letters match up. The derivative of x squared is 2x. The derivative of y squared is 2y y prime. You're now ready to do implicit differentiation. Let's first focus on the left-hand side. The 18, I'm going to just rewrite that. Then notice the parentheses. On the outside of the parentheses, there's a 2 in the exponent. I'm going to have to bring that 2 down, and then my new exponent will be 1. After I do that, again I'm using the chain rule, I have to take the derivative of what is inside. Here it is, 18. I bring down the 2. I have x squared plus y squared to the 1 power. And then I go times the derivative of what's inside. The derivative of x squared is 2x, and the derivative of y squared is 2y y prime. For the right-hand side, xy squared, I'm going to have to use the product rule. So it'll be the derivative of the first times the second plus the first times the derivative of the second. And this is what I get. The derivative of the first is x. The derivative of the first. Okay, what is the first? The first is x. The derivative of x is 1. So the derivative of the first times the second, which is y squared, plus the first, x, times the derivative of the second, 2y y prime. We now have a lot of algebra to do. Let's see, I took 18 times 2 times x squared plus y squared, and I clumped it all together. I'm calling that one thing, and I underlined it in red. I'm going to take that one thing and I'm going to distribute it into the parentheses. So I have to go red times green plus red times orange. When I go red times green, I get this long green. When I go red times orange, I get this long orange. The right-hand side, that's a little bit easier. I'm just distributing 169. All right, next order of business. I'm going to take everything that involves y prime and I'm going to put it on the left-hand side. Everything that does not have a y prime goes to the right-hand side. I'm now work on the left-hand side. The left-hand side has two terms. Both terms have y prime. I want to factor y prime out. I factor it over to the right-hand side, and so I've got this huge parentheses, and then I got y prime. Do you see it? All right. So after I pull out the y prime, I have this red times y prime equals my right-hand side. Okay, so sometimes we forget what it is we're doing. Just to remind you, we're trying to isolate y prime. So my last step will be to divide both sides by this red section. When I do that, I get this rational expression. I'm now going to evaluate the rational expression at the point 2, 3. Before I do that, I do a little bit of footwork. If x is 2 and y is 3, then x squared plus y squared is 13. X times y is 6, and y squared equals 9. So every time I see a y squared, I put in 9. Every time I see an x squared plus y squared, I put in a 13. Every time I see an xy, I put in a 6. After I do that, then I have to do the arithmetic. So on the numerator, I do that subtraction, and on the denominator, I have to multiply and subtract as well. Then I reduce my fraction so that I get negative 9 over 20. All right, now we now have the slope of the tangent line. So we've got a point, 2, 3, and we have a slope, negative 9 over 20. I need to use the point slope form for the equation of a line. And this is what I get. I want to help you figure out where everything came from. So that negative 9 over 20, that's the tangent, the slope of the tangent line. The 2 comes from the fact that at the point 2, 3, x is equal to 2. The 3 comes from the point 2, 3 as well. At 2, 3, y is equal to 3. So the equation of the line that at point 2, 3 with a slope of negative 9 over 20 is y minus 3 equals negative 9 over 20, all of that, times x minus 2. And the rest is cleanup. Distribute the negative 9 over 20, add 3 to both sides, and when the dust settles, this is what I get. And the equation of the line tangent to the graph at the point is y equals negative 9 over 20x plus 39 over 10. This is a rather difficult problem. You might need to watch the video again, but do watch it carefully and let me know if you have any questions. Take care.